on this one, when we do this one out, S1, what is S1 on this one? The first one.
1.
S1 is just 1. S2 is 1 plus a half, which is 3 halves. S3 is 1 plus a half plus a fourth, which is 7 fourths. And S4 is going to be 7 fourths. I'm just skipping that, plus 1/8, which is equal to what? 15/8. So if we're going to write out the partial sums, what does that help us see theoretically? And that's frozen, sorry. What does it help us see? If we write out the partial sums, the sequence of partial sums, this is the first partial sum, that's the second, the third. What does it help us maybe see? A pattern. Math is a study of patterns, right? In this case, looking at the sequence of partial sums, it might lead us to believe that this infinite sum sums to what? What do we think it sums to? Like S, as n goes to infinity, Sn is going to be what?
2.
Yeah, we guess 2. We guess 2, we think it's 2, we will prove it's 2, but having an intuition can help us prove it. What about this next one? S1 is 2. Sorry, I can almost start correctly and read at the same time. 1. What's S2? 3. S3. 7. S4. 15. This one, it looks like, what does it sum to? Does it have a limit? Does this actually target anything? No, it blows up. It goes to infinity. It keeps on getting bigger. What about this next one? S1 is 6. S2 is what? 6 minus 2 is 4. S3 is going to be 4 plus 2/3. I do not like mixed fractions. I want you to write that as what? What do you think I want you to write that as? 14/3. And S4 is going to be 14/3 plus, minus what? Minus what? Minus 2/9, which is 52 minus, again, almost can do math. 42 minus 2 over 9, which is what? 40 over 9. So here's the thing. The first two, we had an immediate intuition about what the actual sums were going to be. On this one, again, this is a word I do not like using in math. Have I talked about this in this class? The word I hate the most in all of math textbooks. Have I talked about this already? It begins with a C.
Clearly.
Clearly. I hate that word. Hate that word in math. That being said, things are relative. Does it look like there's a pattern on the A and B? Sure. One goes to 2. It looks like the next one blows up to infinity. What about this one right here? Is it quote unquote clear? It's a little bit more opaque, right? It's a little bit hazier. It's not as evident. In your notes and in the book, you should have come across a formula for the sum of an infinite geometric series. You remember what the sum of an infinite geometric series was going to be? Artur, what is it? Yeah, I remember I said there was a terrible use of x in this section. I have no idea why they would use x to represent ratio. The way I like writing it and the way most books write it is a over 1 minus r. The first term over 1 minus the ratio. X, I don't, like, stop it. Like, they clearly state that x is the common ratio because the way they define it is they have like ax plus ax squared plus ax cubed. They did that in your book, right?
Yeah,
why? It looks like a polynomial. Stop it. No, don't do it. Don't do it.
Oh, that's what it's like, yeah.
Right. Value. And you're like, stop it. Like, why would you do that? No. So in this case, is there a common ratio between the terms you've seen right here? Well, it's 6 over -2 is -3. -2 over 2/3 is -3. So does it look like the common ratio is -3? It is. On those terms, it is -3. So what's the infinite sum going to be? Well, it's going to be 6 over 1 minus what?
Oh, -1/3.
What did I do there? It's the next term over that, right? Whoops. So what is it going to be? 2/3 over -2. So this minus, whoops, -1/3. So what's that going to be? 6 over 4/3. So that's going to be equal to 18 over 9 over 2. So 4.5. This is also an oscillating series. Bounces up and down. Oh, yeah, okay. That's nice. But sometimes you will need to use a formula. So this one was for an infinite geometric series. There was another formula that you have to memorize. It's got to be just like the quadratic. It's got to be kind of burned into your skull. What's the one for finite? Do you remember?
A
Yeah.
1 minus r
Yeah, over.
One minus one.
Yeah, so if you remember this, you really remember the other one because this only works. This sum only converges when what is true. This only converges. So this one's the infinite geometric series. This is finite, right? It only converges when what is true. This only converges when what is true. Ethan, yeah.
The absolute value of r is 1 and 1.
Yeah, less than 1. Exactly, right. And that theoretically, it does lead to this because if r is the absolute value that is less than 1, n is the number of terms, n is the number of terms. If this is going to infinity, what's 1/2 to the really, really, really big power? This gets infinitely small, so this goes away. If you drop this term, what are you left with? If you drop this term, what are you left with? A over 1 minus r. You just have to be able to use these things, and it's super, 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 super useful. No, I'm not going to have you prove it from scratch, but you will have to do problems that look like, and I'm just going to jump here. There was this example in the book that you hopefully looked at. Let me see if I have it here. Do you remember, is it right here? It's the one about drug dosages. Was that in the book, in the section you did?
Yeah.
And you had this work at the end right here? The term word problems is kind of inaccurate because theoretically you're using words of some sort in all your problems. The word problems for geometric series really just revolve around, can you write what they're telling you as a geometric series? Once you write it as a geometric series, is the math generally pretty straightforward? Factoring is hard, but once you get the factored form of something, it's a little easier to deal with. Once you get, like this right here was the geometric series that the word problem was leading you to. Like the initial dosage was what, 250 milliliters? The common ratio was what? 0.04, right? So you can calculate like how much is left in the system for each of those things. It's not trivial. Setting these geometric series up is not trivial. Like I, every year, do that same problem. I have to read it over and over and over again. It's very similar to finance questions like future value. Has anybody heard the term present value in finance? This goes to 0, so the whole thing goes to 1. So this one right here converges to 1. What about C? Take a look at C, everybody. What do you think?